Applying properties of similar triangles, section 7.4. So we're continuing on with our proportions and our ratios and our similarity within triangles. And now we're going to apply properties of similar triangles. The first one we're going to talk about is the triangle proportionality theorem. The triangle proportionality theorem states that if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So what that means here is if I have two lines that are parallel, it cuts up those lines proportionally. Alright, so again, I look over to my diagram below that, and my lines are parallel. So because my lines are parallel, EG is proportional to GF, and DH is proportional to HF. So I can set up a proportion and solve for the missing values there. Alright, those are the proportions we're talking about. Now the converse of that just says if it makes the proportion, then the lines are parallel. So the converse of it just states the same thing in reverse. So let's look at number 1 here. It says find the length of each segment in exercises 1 and 2. Find the length of each segment in exercises 1 and 2. 1, I want to find the length of RQ. So I want to find the length of RQ. I can label RQ as X. Okay, label it as X. Who can give me a proportion that you would use to set this up? Ryan, what would you say? 6/7 equals 12 over X. Nice job. Now, you could have set it up as 6/12 equals 7 over X. You could set it up the same way. Yeah, there's multiple ways to set it up. It's okay. You just got to make sure you're consistent how you set it up. Now, looking at this, hopefully you can use mental math to solve this and not use cross products. Mental math tells you that the answer is what, Tina? X equals 14. Nice job, ma'am. What about number 2? I want to find the length of JN. I would say that JN is X here. And I want to set up a proportion to solve this. What might be the proportion I use, Bryce?
16/20
and X/38. Nice shot. Again, you could have gone 20/16 equals X/38 or 38/X. Okay, there's a lot of different ways to set these up. Just make sure you're consistent so the parts match up with their corresponding parts. And then now I probably have to use cross products unless you wanted to simplify the fractions and come back up. But then again, I think it's still going to be a decimal maybe. What did you get for an answer here?
30.4.
Thank you, sir. X equals 30.4. Number 3, it says show that TU and WX are parallel. So to show they're parallel, the ratios or proportions have to be the same. So what are my proportions I would use to set up here, Trevor?
15/45 equals 6/8.
And what do both those simplify to? 1/3. So that is true. Correct, sir. Nice job. Take a couple seconds. Try numbers 4 and 5 on your own here. So, number 4. What proportion did you use to set this up, KZ? That would work. 8/10 equals X/15. And what did you get for an answer, KZ? X equals 12. Martina, did you still get the same answer?
Yeah.
Nice job. You can set them up a couple different ways to still get the same answer. Well, how'd you set it up, Martina? And that is just fine. Those are both acceptable ways to solve that problem because you are consistent in how you set them up. What about number 5? How would you set up number 5? Oh, Tom, how'd you set that one up?
I put 1/4 equals 1/x.
And then what's the answer for x?
X equals 4.
X equals 4. Nice job. Now the second part today is the triangle angle bisector theorem. An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the two sides. What that means here is if I have an angle bisector, so an angle bisector cuts the angle in half. If I have an angle bisector, okay, that means these sides are proportional to these sides. Okay, basically what it means is it cuts it up so that it is proportional. And again, they show that BY over YC would be the same as AB over AC. Okay. Again, you can set proportions. As I look down below, okay, find LP and LM. Recognize they compared LP to PN. So they said x over 6 is the same thing as x plus 3 over 10, which is true. Okay. You could have set up another ratio as well and done x plus 3 over x equals 10 over 6, and it would be the same. The thing to note here is if you have multiple x's, you'll have x's on both sides, and you will need to solve, so subtract x to the other side and solve it from there. Yes, Ryan, question? Okay. So let's look at number 6 here. I want to find each length. I want to find EF and FG. I need to first set up a proportion in order to solve those. What kind of proportion could I use to set this up? Bryce, what did you say?
X over 8 equals x plus 2 over 12.
X over 8 equals x plus 2 over 12. I agree with that, sir. X over 8 equals x plus 2 over 12 is correct. And then from here, I would use cross products. So 12 times x gets me 12x. 8 times x plus 2 gets me 8x plus 16. Does everybody see where that 16 comes from? Because you have to distribute. Very good. So from there, I'd solve for x. So I would subtract 8x, getting 4x equals 16. Divide by 4, and I get x equals 4. Is that my answer? No, because what I need to do, I need to plug it in. So I get side lengths that are 4 and 6. Nice job. What about number 7? I need to find RV and TV. And again, remember, this only works when I have angle bisectors. Notice the angle bisectors here. What type of proportion would you use to set this up, Caitlin? What'd you say? 3y over 16? No. No. Camden? 16 over 40? Okay. That would work, sir. What? When you multiply, they will be on cross products. When you multiply, they will be.
Oh, so it can't just be like you can't multiply
It just has to be consistent. Okay? So like 16 and 40, notice that. Put those two together and compare them to y plus 3 over 3y. Again, those would be similar. Those would be similar. 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 Okay? So again, you just have to be consistent in how you set them up. You have to be consistent. There's multiple ways to set it up. Just like the shadow and height problems. You can put height over shadow or shadow over height. It doesn't matter. You just have to be consistent in which way you do it. That's the key. Okay? Now that I have this, I would do cross products. 16 times 3y gets me 48y. Equals 40 times y plus 3 gets me 40y plus 120. And now I would solve for y. So I'd subtract 40y. Giving me 8y equals 120. Divide by 8. And I get y to come out and equal what, Trevor? 15. Is that my answer, though? Nope. Plug it back in. I get side lengths that are 18 and 45. Good work. Take a couple seconds here and try now the next two. Try numbers 8 and 9. So number 8, what proportion did you use to set this up? Nick, what kind of proportion did you use to set it up? Drew?
4 over 5 equals x minus 1 over x plus 2.
That would work, sir.
Wow, good job.
And then you use cross products and you end up getting x to equal what, Camden? X equals 17, which means my side lengths are 16 and 20. Good work, sir. What about number 9? What type of proportion would you use to set up number 9? Jack?
Y plus 1.
What?
Y plus 1 over 14. 2y minus 4 over 21.
That would work, sir. 2y minus 4 over what? 21?
Yeah.
And then you come out to get y equals what?
11.
Y equals 11. Plug that back in, you get 12 and 18. Nice job, sir. That is correct. Again, the biggest thing is make sure you set them up consistently. Here is your assignment.